So today we have a bonus episode. So as you know, bonus episodes are with a big component of fun. They are still informative, but with some fun in there. So for that, today we have invited Ahmad Varasteh. I hope I say it correctly. He's a data scientist at Exorbyte, and he's also an AI educator. And I invited him because people always say, well, you do the data analytics part, you do the data science part, but what is that useful for? What me as a private citizen, as a normal person, what am I going to get out of a project in data science? Today, we are going to see how we can solve, for example, a dinner with murder using data science, and maybe also some real crime using data science. So, Ahmad, welcome.
Thank you so much, Rosario. I'm super happy to be here.
And you can already start and tell us where are you going to take us? Which kind of crime are you going to take us into?
So I'm just going to go ahead and share my screen really quick. And I am going to share my notebook. I'm going to change it to the Zen mode to get more details on the crime series and texts. All right, so here's our scenario. A fugitive suspected of being a cartel member vanishes after committing a violent crime. The individual had been under police surveillance for weeks, but investigators lost track of them at the city's central station. Authorities believe the suspect arrived at 1710 and purchased a ticket within a narrow window of 2 minutes before disappearing. During the same time frame, 20 passengers also purchased tickets to different destinations using credit cards. Surveillance footage confirms the fugitive was present at the station, but investigators cannot determine which ticket was used for the escape. Now, to support the investigation, the law enforcement provides two data sets. The ticket underlying purchases at CSV, that is basically the train tickets that was purchased during that 2 minute of window. And we have the card transaction activity, that is 1 week of transaction history for 20 credit cards used by the passengers. Now, of course, we're going to have a look at these data sets really quick. And so let's talk about our task here. So the 20 passengers who purchased the tickets during the 2 minute window all use credit cards. So your task as a data scientist is to analyze 1 week of their shopping behavior to identify which credit card belongs to the suspect. By detecting unusual spending patterns or movement behavior from the transaction history, we are going to isolate the suspicious credit card and then find out where our fugitive escaped to. All right, so let's begin our investigation. So the first thing that I need to do is to import all of the needed modules. I'm going to run the code, and I'm going to use pandas as PD, NumPy as NP, and for the data visualization purposes, I'm going to use Plotly Express as PX. So firstly, we are going to have a look at our ticket purchases.csv. So if you look at this data set, this is the first data set that we've been provided. These are the tickets that are purchased in the 2 minutes. So each row is representing the ticket ID, the card that was used to buy the ticket, the destination, and the train number that the person took. And of course, we have the timestamp that refers to the time when the ticket was purchased. And of course, if you look at all of these timestamps, we can see that the timestamp is between 1710 to 1712. Now, we have 20 different tickets bought by 20 different cards, and we know that one of these cards in our dataset is related to our suspect. So in this analysis, we are going to find which of these cards is related to our fugitive. All right, so now let's have a look at the second data set. So here I have the card transaction activity. Basically, this data contains of 1 week of shopping activity related to all of the different 20 cards related to all of those people who bought ticket in that 2 minute window. In each row, we have a transaction ID. We have a timestamp that shows when the transaction has happened, the card that was used to do the transaction, the merchant ID, that is the unique merchant ID related to where the transaction has happened. We also have some geo information in this data. We have the registered address location of the card holder or associated registered address to each card. That is the latitude, longitude information of where this location is. And of course, we have the amount in USD. Amazing. So now let's have a look at our investigation objective. So the goal of our investigation is to analyze this data set, the credit card transaction, to identify behavior patterns that may reveal the fugitive identity. Now, You see, when individuals are under stress or attempting to evade authorities, their spending behaviors changes a lot. Because they're under stress, they think that they are under microscope, so they behave strangely. In other words, they are very different when you're looking at their behavior. Their shopping behavior is super different from other different normal citizens, right? And there are some behaviors like bursty transaction behavior. That means there are rapid purchases within the short period of time, or some suspicious movements patterns. They basically hop around the city. They try to hide their tracks, so to say, when they are visiting a merchant and when they are shopping. But the question is that how, as data scientists, from data science perspective, we are going to solve this problem. How can we analyze behaviors out of this data? So the thing is, we can look at this data from two perspectives. The first thing is the temporal shopping behavior.
Actually, one thing that I'm curious about is where this fugitive went.
Yeah, exactly.
Of all
So
those
that's
cities. If I were a fugitive, where would I go? Which would be my preferred city?
Leipzig.
I think I have an idea.
I'm gonna give you a hint. Leipzig.
No, it's okay. I want to discover that. I want to see if
Yes.
my feeling is
Of
correct.
course.
Okay, so
Of
we are
course.
going to go for the temporal behavior and the
Yes,
geographical
exactly.
behavior. Okay.
Exactly. So, and then in order to analyze that from a data science perspective, we need to compute some statistical measures that capture the temporal dynamics and some statistical measures that captures the geographical movement behavior, right? And then after that, we're going to combine them to have a sort of an overall overview of the whole behavior of each cardholder. And then that is when we are going to compare the behavior of different cardholders that we have, right? To hopefully find our fugitive. Amazing. So now let's go ahead and have a look at our first measures and the things that we are going to calculate. If I have a look at my data set, this is the main data set that I'm going to work with. So the first thing that I want to do here is to only keep those columns that I need for this analysis. So I'm going to go ahead and pass this variable, this list here, needed columns, into this data frame. I'm going to make a copy of it. I'm going to go ahead and say timing underline df. I'm going to store it into a new data frame. Let's have a look at this data frame together. Now I have only the card ID and the timestamp information. Now, if I have a look at the data types, the different data types of these columns, I can see that the timestamp is an object or a string in Pandas. The first thing that I want to do is to transform the data type of this column into a date time, so I can actually make use of Pandas date time object and methods, right? And in order to do that, I'm going to go ahead and say, okay, so I'm going to get the column, and there's a method in Pandas called pd to date time, and I'm going to pass this column into this method, and this will return a new Pandas series to me. Let's have a look at the D types again, and here we go. So the timestamp is converted into a date time, 64. Now, the second thing that I want to do, if I have a look at the data again, is that what I want to do is to sort the values, sort the timestamp for each card, so that I have all of the transaction related to one card in an order in time. In order to do that, I can just say sort values by, and I'm going to pass in both of these columns, card ID and timestamp, in here. And I'm going to store it back into the same data frame. Let's have a look at it again. Now we have everything in order. Yes, we have the time sorted, and then I want to calculate the time difference between two consecutive transactions to basically find out what are the time difference between two consecutive transactions.
So you want to see the elapsed times.
So basically, yeah, I'm calculating the time difference, and then I am calculating the average delta, median time delta, and the 10th percentile. So basically to show how fast they are actually doing. Basically a simple distribution analysis, right? And then I'm going to have for each card, I'm going to have 3 measures that show their temporal behavior, right? And then I jump to the geographical movements. For the geographical movements, I am going to calculate the Haversine distance, the distance between 2 latitude, longitude on Earth. And then basically, again, for the distance from home, I'm going to calculate these measures. And I have a code ready here. And these are like some measures that can describe the geographical behavior of where they moved, how they moved around the city when they were shopping.
So what do you use as a home?
There is this registered.
Okay.
Yeah, there's this registered address location for each card.
The
It's
one
like
of the
that's the
card.
central
Makes
point.
sense.
Yeah.
Makes sense. Yeah. So so the farther away from home, the more suspicious it is, unless it's on vacation.
Exactly. So I mean, one
Okay.
of them is average distance. Yeah.
Sounds good. Sounds plausible.
And then after that, I combine all of the measures into one data set, use PCA, reduce the space, scatter plot, and then find the outliers. Basically, that is my plan.
Okay.
All right, let's go. So I want to find a time delta, a value that shows the time difference between two consecutive transactions. In order to do this, basically what I'm going to do is that I'm going to group by this data by card ID, and then I am going to get the timestamp column. And because this timestamp is a datetime object, I can just easily go ahead and use the diff method that shows the time difference between two consecutive rows for each card. So if I run this, I'm going to get a new pandas series that shows the time difference between two consecutive rows in my data. But the thing is, the granularity is in days, but what I want is sort of a measure that is easier to compare. So what I want to do is to have that time delta in minutes rather than on days. So what I'm going to do here is to get access to the datetime object of this pandas series and then call total seconds. When I get the total seconds, I can just easily divide by 60 to get a new column that is basically the time difference in minutes. I'm going to go ahead and store this into a new column called time delta. All right, so now I have a new column that shows the time differences between two consecutive rows.
The first one cannot be the fugitive.
No, these are the time series. So basically, where each row is showing the transactions in order in time, right?
Yeah.
And then I have all of this data has 20,000 rows, and I have all of the transaction of all of the cards in here. All right. So now, based on this time delta, I'm going to use statistics to calculate some simple measures that are showing temporal behavior. For example, for each card, I can calculate the average time delta. That is the average time between purchases, basically showing an overall transaction frequency. A card is suspicious if actually this average is a super low value, right? Or I can calculate the median delta in minutes. That is the typical time gap between the purchases. That's the middle value in the distribution of all of the time delta that I have. And the other important thing is the 10th percentile delta, that is the time gap below which the fastest 10% of transactions occur. Basically, we can using this measure, we can capture if there's any rapid bursts or activity while shopping for each card that we have. So in order to do this, all I have to do, I'm going to go ahead and say timing underline df, and then I'm going to go ahead and group by based on the card ID. I'm going to get the time delta because I want to run all of the aggregation function on this method. And in Python, you can easily use aggregation method to apply several aggregation functions at the same time to a column. So the first one that I want to calculate is the average delta in minutes. And I can pass in the name of the method I want to use to calculate the average delta mean. As a string, right? And then the second one is median delta in minute. I'm passing in the median. And I have P10 delta mean. And in order to calculate this, I'm going to use a lambda function that gets a group of the cards. So this G is actually representing all of the cards with the same card ID. And what I do is that I say G.quantile 10%. This will give me the 10th percentile delta, right? And now if I run this, let's actually reset the index after group by. Let's store this into the same data frame, and then let's have a look at this data frame again. All right, so now in here for each card, in this data set, for each card, I have 3 numerical measures that are basically describing the temporal behavior while shopping for each of the cards that we have. Amazing. So now the second aspect of...
And you already see something. They look all the same to me. You do.
Yes, but only in average.
You will. Okay.
Only on average, because average always, well, not always honest with us, right? When you're analyzing the distribution, because it hides the big numbers in the distribution, big and low numbers, the extreme values in the distribution. All right, so now let's go ahead to the second part of our analysis, which we are going to analyze the geographical movement patterns. So as we discussed, the fugitives often operate far away from their home base and frequently hop between different merchants to avoid leaving a concentrated trail. And so in order to basically start this analysis, let's have a look at our data again. So as you can see here in this data, we have some columns that represent some geographical information to us. We have the registered address location, that is the registered address associated to each card or each cardholder, or basically it's the home address of each cardholder. We have the merchant location where each transaction happens. So basically what I want to do is to calculate how far from home each transaction has happened for each of the transactions that we have in our data. So, but the first thing that I want to do is to actually clean up a bit. I'm going to create a new variable called geo_df, and I'm just going to get the needed columns for this analysis. And then I'm going to make a copy of it. So now in here, basically this data set shows for each card, which card was used in the transaction, where it was basically registered, the home address of this cardholder, where the transaction happened, and I have also the merchant ID, the unique ID for each merchant. Now the first measure that I want to calculate here that help us to analyze the geographical movement behavior is I want to know that so how far away from home each transaction happened. Basically, I want to find the distance in kilometers between these two geolocations, between these two latitude and longitude. And in order to do that, I'm going to use Haversine distance. And Haversine distance is a formula used to calculate the shortest distance between 2 points on Earth's surface, to latitude and longitude, in kilometer. Because we are not going to go into the details of this, we're going to use this already written method in here called Haversine, gets 2 location information, basically 2 pairs of latitude and longitude, and will return the distance between 2 pairs in kilometers. Now, what I want to do here Now, in order to calculate the distance between these two, all I have to do is to loop through this data frame row by row and apply the method to each of these pairs that I have. So in order to do this, I'm just going to go ahead here and I say geo_df, and I'm going to use the method apply, and I'm going to define a lambda function that gets a row and basically call the Haversine km, this method here, and as the arguments, I'm going to pass in the 2 columns that we have. The first one is basically the registered address. I'm going to be lazy and copy and paste it from here to here. And the second argument is going to be the merchant location, right? And then I need to actually specify the axis. This is basically specifying that I want to loop through my data frame row-wise and not column-wise. And then I'm just going to go ahead and store it back into my data frame. Well, actually, let's have a look what this returns to us first. I'm going to run the block. There is an error here. Check the error. Merchant's location. It's probably with a capital L. Block. Again, and here we go. So basically, I have a list of numerical values that are basically the distance in kilometers. So how far away from home did they did their transaction? So I'm going to go ahead and put this into a new column in my DF, and I'm going to call it distance from home in kilometers.
So now you have the information about the frequency of So the time, the temporal pattern of buying, and you have the information about where.
Exactly.
Okay.
Exactly. And how far away from home. And the
Okay.
thing is, right now, I can even use this distance from home feature to extract even more information that can help me analyze the geographical information. Now, what I want to do, as I said, to use this to extract some other measures that could be helpful to analyze the geographical movement behavior of each cardholder. For example, the average distance from the cardholder's home where the transaction occur, basically showing the average radius, how do they travel, how much far away from home on average they travel, right? Or the median distance, the typical transaction distance from home. Maximum distance, the upper boundary of the travel behavior or the lower boundary travel behavior. This all could be helping me to analyze a person's behavior. And the other thing is merchant count, right? So I want to know the number of unique merchants that was visited by the person during 1 week. And that is actually a very good measure to identify the person, because people who are fugitive, basically they try to hide their trail by not going to the same place twice, right? And in order to calculate this, I already have the code here. Basically, I'm going to group by again based on the card ID and calculate these measures. So I want to find the average of the distance from home, median value, maximum value, the upper boundary and the lower boundary, and the number of unique merchants that was visited by the person. If I run the code, I am going to have this data. Basically, now for each card, I have 6 different numerical measures that are describing how did they behave in 1 week, the geographical movement of the shopping activities, right? And now, if you remember, as Rosaria mentioned, we had also already some information about the temporal side of our analysis, right? And now what I want to do is to combine both of these informations to create one data set. So in order to do that, I'm going to go ahead and call merge method. I'm going to merge based on the card ID column, and I'm going to merge GeoDF. So basically, I'm merging the timing DF and GeoDF on the card ID together, and I'm going to put it inside a data frame called DF, and I'm already going to make a copy of it. Let's have a look at this DF, and here we go. Now, this dataset is showing 9 numerical measures related to each card to describe both the temporal and geographical behavior during 1 week of shopping activity. Now, it is time to actually find the card to compare these behaviors across 9 dimensions and find the card that behaves differently in terms of both type of behavior, temporal and geographical. Now, the thing is, how can we do it? In data science, there is a technique called outlier detection, Rosaria, right? That rings a bell. So basically, it's a technique where we find the data point that behaves differently from the other data points in the data set, right? And in our case, in our story, that data point is our fugitive, is our suspicious card, right? Now, there's a problem here. These 2 behaviors are described within a 9-dimensional space. And finding an outlier in 9-dimensional space, that means to take a look at all of these individual columns and find the suspicious card. But data science made it easy by a technique called PCA, or principal component analysis, where we basically reduce the dimensionality from a given feature space into a lower dimensional space. So PCA is a technique used to reduce the dimensionality of the data, of the numerical features, while preserving the information within the features. Basically, what I want to do is that I want to use PCA to basically crunch all of these 9 numerical features that I have into a smaller set, into 2 features. So I want to describe the behavior of each card instead of using 9 numerical features in only 2 numerical features. So let's go ahead and have a look at this here. And so I have implemented a method using Python. So here we have PCA from the decomposition from the sklearn, and we have also a standard scaler because we need to scale the features before we run the PCA. We're not going to go deep into PCA right now. But yeah, basically I have a method here that gets a data frame, the features that I want to reduce them into a lower space, the number of space I want to reduce these features into, and some additional inputs, right? Let's go ahead and run the PCA on our data frame. The first thing that I need is a list of features. So in order to do that, I can say df.columns. Let's have a look at this. So I get a list of all of the columns. What I need is only to reduce these dimensions. These are the features that I need. So basically what I do is that I just simply say I want all of them except for the first one, and I convert it into a list. So I have the 9 features here. Now I'm going to go ahead and say run PCA. I'm passing in my data frame, the features, and I want to reduce them into 2-dimensional space. And I'm going to run the code, and here we go. So now the geographical and temporal behavior of each card can be also represented in 2 columns, PC1 and PC2. Now, basically, very easy. I can just use a scatter plot to visualize each card behavior, right?
So will you do it or not?
Yes, I will.
So you can easily do it. Does it mean that? Or you can easily do it and I don't understand. I'm waiting
I'm gonna
for
do it.
doing.
Yeah. So, and then now I'm gonna use a scatter plot to visualize this information to find our outlier. So in order to do this, I'm gonna go ahead and create a scatter plot. So I can say px plotly express, my favorite, that's scatter, and then I'm passing in the data frame. In the x-axis, I want to have the first principal component, and in the second axis, I'm going to have the second principal component. So I also want to have a hover name. Basically, when I hover over a data point, I want to see the card ID, so it is easier to perform the analysis. I'm going to run this. Now we are going to have this beautiful...
There is.
Yes, this beautiful scatter plot. So on the first side, we can see that there is a data point here. So basically, each of these data points is representing each card, right, in our space. And we can see a huge cluster here. Because the behavior of these cards are close to each other, they formed a cluster here. And that means that they are normal citizens because they behave similarly, right? And the suspicious card is actually the one that is not having a normal behavior in time and geographical information, of course. And if I hover over this, I can see that card 07 is my suspicious card. Of course, I have another card is card 12, but if you compare them, I mean, yeah, maybe it's just a normal citizen like the other ones.
Somebody goes on vacation from time to time.
Exactly, somebody went on a vacation or had some stress shopping,
Yeah.
Yeah. And then so card 07 is our fugitive, basically. Now, if you want to know where this guy went, I can just have a look at our tickets data set again, right? And now here we go. So card 07, yes, took the train number took the train number IC 800 to Leipzig at 7:10:37.
I would have bet it would go to Berlin.
Yes. Well, these names are just random, Rosario.
Yeah, sure. Okay.
All right.
This is the conclusion.
This is the conclusion, yes.
Very spannend, as they would say in Berlin and Leipzig.
Yeah. Amazing.
It was very exciting. No, it was very exciting. I didn't know who was going where and who was the fugitive. No, it was very nice. It was very nice. And actually, it shows that you can use the data, just analyzing very basic data processing. You can already detect patterns in the data.
Exactly.
Even without, going into the AI or into the super cool, fancy models.
Exactly.
You can already isolate the strange behavior.
Yeah, exactly. And it's really interesting because when I'm teaching theoretical machine learning or statistics, the students are usually like, okay, now I know how k-means work, right? And I know how KNN works. But am I going to use it somewhere ever in the future and work? And this kind of sort of scenario-based courses are actually super helpful for the students. I mean, I would say it's super nice to both teach and learn data science at the same time.
I also was pleasantly surprised about the usage of the PCA because I thought, okay, so there is the data, but now you have all these dimensions. So what are you going to do? And so
Yes,
frankly, the
exactly.
PCA made it much, much easier. And then, of course, the famous scatter plot that I didn't know if you wanted to use or not.
Exactly.
No, very interesting. Very, very interesting. Okay, so how many of these kind of stories do you have?
Well, basically, I think I designed during some free times last year. I designed like 10 of them. As a kid, I really loved the crime stories and murder mysteries, right? And then so I was like, well, look at all of these detectives, how they solve their problems, but they're basically what we are doing as data scientists, right? So we find facts, we put them together, and we basically reach to a conclusion about a problem. And then I was like, okay, what if I can like recreate this sort of stories using data, right? And you can bring in a lot of interesting statistical analysis, a lot of predictive analysis into the story and help the students to understand using in a fun way to understand basically basic data science.
So do you
as well
teach those stories, or do you have
Yes, I do. I mean, I do it on my YouTube right now. So I made a playlist of this. I
so that's
have
where
a
I
new
saw them,
collection
right?
coming.
Yeah.
Exactly. I have a new collection coming in that I am going to solve crimes using agentic AI as well. So to understand the basic of prompt engineering, prompt chaining, all of the routers and so on. And it's going to be super, super interesting, I would say.
So which kind of stories do you have besides the fugitive on the run?
Well, I have like, for example, the famous death on the train, right? So it's
It
very
has to be.
typical
There
one.
must be a murder somewhere.
There
It
was
has to be.
exactly, yeah.
It has to be.
Yeah. I mean, in most of them, there's basically a person missing or a person did a crime, and then there is a data set designed around that story to basically shape the whole course around it.
Okay. Very, 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 very interesting. It was fun. It was fun to watch how the plot evolved,
Yeah. Yes.
displayed. Yeah. And,
Yes, of
in
course. I hope that it was also
real
enjoyable
time.
for the.
And the code was not too complicated. I mean, that's really a few steps that you can put together and you already reach some conclusions. How big was the data set? I didn't ask. I saw a 10, 11 of these kinds.
Yeah, so the data set was, so it contained 20 cards and 20,000 rows basically was in the transactions data set. That was like 1,000 rows per card that I had. Yeah, and so if people are interested, they can also find these crime stories with all of the materials on my GitHub. Have a look at them, try them out. The
I will
notebooks
put the
are the
link
data set.
on the description of this video. Yeah, absolutely. Thank you. We have discovered
so much,
something new
Asaria.
today. We also had a bit of fun with the little crime adventure and the fugitive on the run and the Deutsche Bahn as well. So I think it was
Yes.
it was a very interesting story that we got told today with data and with a bit of transformation of the data. Thank you for Ahmad for the interesting code experience and for the interesting story experience. And thank you to the audience for listening to us until the end. I hope today you had fun in this bonus episode.
Thank you.
You're giving me